Okay, hey everyone. So I think we'll just start now. So I've just done a workaround. I'm displaying the slides on the main computer instead of my laptop, and so we can just continue. And this projector is just not working. So so welcome back everyone to the last lecture of the course. Right, so this lecture is just going to be about the course review and talking a little bit about the final exam. So it's going to be a fairly short lecture, depending on how many questions you guys have. Okay, so first of all, let's talk about the course. All right, so at the beginning of the course, so what did we tell you about COMP2521? So in comparison to COMP2511, which got you thinking like a programmer, the main purpose of COMP1511 was to teach you how to solve problems in C, right? Relatively simple problems. So, how to develop programs to solve problems and express your ideas in C. And what is this course about? Right, so this course is not to just get you thinking like a programmer, but to get you thinking like a computer scientist. Right, and what does a computer scientist know? Well, computer scientists should know, a set of fundamental techniques, algorithms, and data structures, and they should be able to reason about the applicability of data structures, algorithms, and their effectiveness. Right, so they should be able to take a data structure or algorithm and analyze how good it is in terms of its time complexity, space complexity, and be able to decide when the data structure or algorithm is suitable. Right, in which circumstances should I be using this data structure, and when is it better to use some other data structure. Okay, so what have we learned over the span of the 9 weeks? We'll take a quick break here. Okay, so let's continue. I'm sorry for that disturbance. So, right, what have we learned over the span of 8-9 weeks? We've covered a whole bunch of data structures, right? Trees, graphs, hash tables, heaps, tries. We've covered a whole bunch of abstract data types as well, including stacks, queues, sets, priority queues, right, and more. And we've also talked about how to analyze these data structures and algorithms in terms of their time and space complexity. We also went through a bunch of sorting algorithms earlier in the course, and a bunch of searching techniques, including linear search and binary search. And we also went through a lot of graph algorithms, including graph traversal, BFS and DFS, a bunch of algorithms on weighted graphs as well, including Dijkstra's algorithm, Prim's algorithm, Kruskal's algorithm. All right, so with all of that knowledge, what do we expect you to be able to do? All right, so with all of these new data structures and algorithms, we expect you to be able to implement solutions to a wider range of problems now, right? And you've solved a lot of these problems in your lab exercises and in your assignments. We expect you to be able to analyze performance characteristics of algorithms, so time complexity and space complexity again, and same thing for data structures. And we expect you to be able to make decisions about appropriate data structures and algorithms. And so, for example, given a problem, which of a set of data structures or algorithms is most suitable for the problem. Right? So, for example, say you've got a problem and you can solve it using a AVL tree or a hash table, right? So, in what situations would each of these be appropriate? It depends on the problem. Okay, so now we'll just go through all the topics in brief. So we covered a bunch of data types, and for each of those data types, we considered their implementation in C in terms of their data structures, their struct definitions, and their functions. We talked about all the various operations that can be performed, and the most common ones would be inserting, searching, and deleting, or in some cases traversing. We also analyzed how efficient their operations are, and we looked at some applications of each data structure. All right, so the topics that we covered. So first of all, we went through recursion, because recursion was a really useful topic later on in the course. Right, so recursion, remember the fact that we can create recursive helper functions, right? Because sometimes instead of just recursing directly, you have your data structure consists of a wrapper struct, right? And then for linked lists, you would have a wrapper struct and linked list nodes. In that case, you would need a recursive helper function. Right? And in other cases, you might need to pass additional information into your recursive function. Right? So in the case of graph traversal, DFS, right, we need to pass in a visited array, and that's why we need a recursive helper function. Okay, and yeah, we ended up using recursion throughout the course, right, with trees, with graphs when performing DFS, and even in tries last week. And in sorting algorithms as well, when we're talking about merge sort and quick sort. Okay, we also went through analysis of algorithms early on, right? Talking about empirical analysis. So that's when you measure how long the program takes and then use that to determine how efficient the program is. In terms of how fast the amount of time taken grows as the input size increases. Right, we also looked at theoretical analysis, which is where we look at the algorithm and count the number of primitive operations that it performs. We saw later on that we don't need to necessarily count the number of primitive operations, but we can just count how many times each line is executed. And we also saw that instead of counting how many times each line is executed, we can also just look at how many times each loop iterates, right? Or how many times a function recurses. So all of these ways to simplify how we can analyze algorithms. And we also introduced the idea of time complexity and big O. Big O notation is what we've been using to express time complexity throughout the course. Okay, what did we cover next? So we talked about a bunch of sorting algorithms. We went through sorting algorithms very early on because it was a good way for us to practice our time complexity analysis, right, in terms of best case, worst case, average case. Right, so with sorting algorithms, we went through a bunch of properties of sorting algorithms. We looked at their time and space complexities. We looked at whether each algorithm was stable or not, and whether each algorithm was adaptive. Right? And in terms of what sorting algorithms we talked about, we looked at selection sort, bubble sort, insertion sort, and shell sort. So these were the elementary inefficient sorting algorithms. And then we talked about divide and conquer sorting algorithms, which is sorting algorithms that break up the problem into smaller pieces and then recursively sorts each of those pieces. So those would be merge sort and quick sort. Then we looked at non-comparison based sorts. So with the other sorts, selection sort up to quick sort, these algorithms are all comparison based, and we looked at the fact that comparison based sorting algorithms, the best you can do with them is n log n in the worst case, right? So there are some other algorithms which have a better worst case time complexity, such as radix sort, but these sorting algorithms require us to make some assumptions about the inputs, right? In particular, radix sort requires us to break up the input into individual symbols or characters. Okay. All right, so after sorting algorithms, what did we talk about? We introduced the idea of abstract data types, right? So remember, what is an abstract data type? It's a data type that is specified based on its high-level behavior rather than its implementation. Okay, so examples of these would be stacks, right? Stack is an abstract data type where you've got two main operations, push and pop. We've also got queues, which is an abstract data type where you've got enqueue and dequeue. And we also talked about sets, right, which is just an unordered collection of elements. Okay, and we also looked at various ways of implementing these abstract data types, right? So we looked at linked list implementations, array implementations. With sets, we saw that an unordered array was quite inefficient, right, because of the need to perform a linear search. Right? We could also implement it using an ordered array, right, which allowed us to use binary search, right, in order to search for an element. But the downside of an ordered array is that you need to perform shifting, right, in order to keep the array ordered whenever you insert an element or delete an element. Okay. Yeah, and that led us to the topic of trees, right, which allows us to solve the problem of shifting, right, because trees are a linked data structure, like a linked list, and when you insert into a linked list, after you've found the place to insert, you don't need to perform any shifting, right? You just need to manipulate a couple of pointers to insert. And trees allow us to do something similar, right? Except they also allow us to search very efficiently, right? Unlike linked lists, where you have to start from the beginning and go, traverse linearly all the way to the end. But with trees are a branching structure, and whenever you search in a tree, you either go left or right, and that allows you to, eliminate, roughly half of the tree, half of the search space, if your tree is relatively balanced. So we looked at tree terminology, tree properties. The most important property is the height of the tree, right? Because the height of the tree influences how efficient searching is, how efficient inserting is and how efficient deletion is. All right, and yeah, we looked at binary search trees, and then we looked at balanced binary search trees, right? Because binary search trees themselves aren't necessarily balanced, right? They could be very unbalanced, which would mean all your operations would still be fairly inefficient. But with balanced binary search trees, their aim is to make sure that the height of the tree is O of log n, right? Which allows more efficient insertion, search, and deletion. Right, and the one kind of balanced binary search tree we looked at was AVL trees, which are binary search trees that remain height balanced. Right, so what is height balanced? Well, a height balanced tree is one where for every node, the difference in height between the left and right subtrees is no greater than 1. Right, and we saw that in order for AVL trees to remain height balanced, they need to perform rotations. Right? And the sequence of rotations that need to be performed depends on what case or where the value was inserted, which subtree is taller. Okay. So after looking at AVL trees, we switched over to the topic of graphs. Right, so remember, what is a graph? A graph is a collection of vertices and edges, right? And graphs allow us to represent lots of different kinds of scenarios in the real world where you've got entities and relationships between entities, right? So in particular, you've got your road network, right? That would be easily represented using a graph. We've got what are the scenarios? So the internet would be an example of a graph, and lots of other examples. So social networks is another example. Okay, we looked at a bunch of terminology and properties. We looked at 3 main kinds of representations for graphs, which were adjacency matrix, adjacency lists, and array of edges. And we analyzed each of those. Then we went on to look at graph traversal. So, given a starting point, traverse, all the nodes, vertices of the graph. Right? And there were 2 main ways of doing this, which were BFS and DFS. Right, so differences between the 2, remember that BFS visits vertices in order of distance from the starting vertex. BFS uses a queue, and it lets us find the shortest path, right, from one vertex to another vertex or to all other vertices. Right, DFS is a graph traversal method that uses a stack. Right? And the nice thing about DFS is that it can be implemented recursively. Okay, then we went and looked at different graph problems, such as cycle checking, connected components, and Hamiltonian paths and Euler paths and circuits. Okay, and that's the moment where we took a week break for week 6. So when we came back, we started looking at, so first of all, digraph algorithms, which aren't mentioned here. But we saw that digraphs can be directed graphs, can be traversed the same way as undirected graphs. Right, we looked at how to check for cycles in a directed graph, and we also looked at an algorithm for computing reachability, or the transitive closure, which was Warshaw's algorithm. Okay, then we went on and looked at algorithms on weighted graphs, which were Dijkstra's algorithm, which we used to find the shortest path in a weighted graph, and also a bunch of minimum spanning tree algorithms, which were Kruskall's algorithm and Prim's algorithm. All right, and that was the end of graphs. Right, then we went on and looked at hash tables. Right, so hash tables, a very important topic because they are used everywhere in the real world, right? Lots of languages have hash tables built in, either into the syntax or as part of their standard library. So we talked about hash functions, which is how a hash table decides, where to insert an item. And because of the fact that hash tables are implemented using an array, which is much smaller than the range of possible values or keys, we inevitably end up with collisions, right? And so we examined different ways of resolving collisions, namely separate chaining, which is where each array slot has a linked list of items, linear probing, which is where if you get a hash collision, you simply look at the next slot and you keep going until you find an empty slot, or double hashing, which is where if you have a collision, you use a secondary hash function to decide your increments and then use that as your increment when searching for an empty slot. Okay, and since hash tables are so common in the real world, we also looked at applications of hash tables, including how to use hash tables as a set, how to use them as a counter, and in last week's lab, you guys had a lab exercise where you went through implementing a hash table and also solving some problems with them. Okay, then we went on and looked at priority queues. So remember, a priority queue is an abstract data type where you can insert an item with a particular priority and then delete the item with the highest priority, right? And we implemented priority queue in various ways. So in particular, we implemented them using an unordered array, right? And with an unordered array, the advantage of that was insertion was really efficient because you just insert at the end of the array, but deletion was very inefficient because you need to perform a linear search to find the highest priority item and then shift everything down. Right, then we tried implementing a priority queue using an ordered array, right? And with an ordered array, we saw that inserting was now inefficient, right? As whenever you insert, you need to make sure the array is ordered, which means you need to perform shifting. Whereas deletion was very easy because if the highest priority item is at the end of your array, then you just remove it, and that's it, no shifting required. Right, so the unordered array and ordered array are like opposites in which operation is more efficient. Right, so with an unordered array, we had O1 insertion, ON deletion, but with an ordered array, we have ON insertion, O1 deletion. Right, then we looked at a really cool data structure called a binary heap, which lets us solve both of those operations in O log n time. Okay, so after that, we had a brief look at tries, which is a data structure that allows us to efficiently store strings. Right? And it's a data structure that allows us to perform searching on strings, and we can use it for applications such as predictive text and autocomplete. Right? Whereas with hash tables, even though they're very efficient, they're not very good for implementing predictive text or autocomplete, because in order to search in a hash table, you need to provide the full string, right, or key. Whereas with a try, you don't need to. Okay, and that was all of the content of the course. So now switching over to the assessment. Right, so let's remember, where, what your mark comes from. So we have weekly labs at 15%, and we have 8 labs. So we are taking the best 7 out of 8 labs when calculating this 15%. Right, we also got 8 quizzes. The last one is due this Friday. And we take the best 7 out of 8 quizzes to calculate the 10%. Right, then we also have 2 assignments, so both 15%. Okay, so the first assignment, the marking should be out by either Tuesday or Wednesday. So for some of you, the marking's already been released, but all of it should be released by Tuesday or Wednesday. Okay, then you'll be able to apply your style marking feedback for assignment 2. And then assignment 2 was about graphs, and that is due this Friday at 8 p.m. Right, and we'll try to get the order marking at least for assignment 2 out before your exam. We'll try, but the style marking, that will have to wait because your tutors will also have exams, so they'll be busy studying. Okay, and the final exam is just what's left, right? So 45%. And to pass the course, you need to score at least 50 out of 100 overall, just like with any other course. And you need to score at least 40% on the final exam, right? So that's 18 out of the 45%. Okay, so let's talk about the final exam, and you'll get a chance to ask questions about the exam here as well. So let me just try to bring up the live stream on my phone so I can see the questions, if there are any. Okay. There. So. Okay, I've got it now. All right, so the final exam. So I've already posted some information about the final exam on the course website, so a few weeks ago, I think now. So this will be reiterating that information quite a bit. Okay, but just to talk about the final exam. So it's going to be a 3-hour exam. And so I've got, it's going to be 10 minutes of reading time and then 3 hours of working time. And it's going to be on Monday, the 27th of November, so 2 weeks from now. Well, it's going to be held in the CSE labs, and it's going to be a closed book exam, which means you can't bring any materials with you into the exam. All right, so the materials that will be provided will be the lecture slides and lecture code. All right, and there'll be a C quick reference, but hopefully you should know how to program in C enough not to need this. All right, and yeah, so that's all the resources that's going to be provided. So no lecture questions and answers or lab exercises or solutions. All right, and there are 2 sessions. Right, because there are so many students, we can't fit everyone in one session, so we have 2 sessions, morning and afternoon. And you have been sent an email to indicate a preference. So you should have been sent an email this morning, I think. So did everyone get an email? Yes, good. I can't show you on the big screen because I'm using the monitor. But yeah, there's a form you can select morning or afternoon. If you have another exam on the same day, you should have been automatically allocated to the non-clashing session. All right, and yeah, it's first come, first serve, so make sure to indicate your preference now if you haven't already. All right, and you'll be sent an email with your allocation in early week 11. Right, so early next week, you'll be told, if you're in the morning session, you'll be told what room and what computer or what seat you'll be sitting at. If you're in the afternoon session, then you'll be told a room where you gather before you actually move to the lab computer rooms. Okay. Yep, so to prevent communication between students in the morning and afternoon sessions, students in the morning session can't leave early. Students in the afternoon session will be corralled before the end of the morning session, and students in the afternoon session are not allowed to be late. Okay, because if you are late, then you could have communicated with someone in the morning session after they left. Okay, exam conditions. So on-campus exam rules apply, so you can go and have a look at this. Okay. So what items or materials are you allowed to bring into the exam? So first of all, you have to bring your UNSW student ID card, right, so that we can identify you, make sure that you're the one sitting the exam and not someone else. And the ID card must not be expired. Okay, so just make sure to check your ID. There should be an expiry date. If it's expired, then make sure to get a new ID card. Right? So there should be a lot of time to renew your ID card if you need to. Okay, you may bring a clear water bottle. All right, so recommended because you should stay hydrated while you're doing the exam. Yeah, make sure it's clear, so make sure there's no writing on it. You're allowed to bring a clear pencil case with pens and pencils. And all other items you're not allowed to have with you at the table, right? So all other items should be placed in your bag, and the bag will be placed at the front of the room. In particular, phones, smartwatches, or electronic devices must be switched off and placed in your bag. Okay. Yeah, and yeah, don't violate exam conditions. Okay, what's next? So the exam environment. All right, so I announced yesterday that you'll get a chance in your labs this week to try out the exam environment. So, if you're interested in trying it out, go to your lab. Okay, so a little bit about the exam environment. It's a restricted environment, so it's not your regular CSE account. That means you won't have access to the files in your CSE account, right? And no access to internet, so no ChatGPT. Right, so in the exam environment, there'll be a bunch of different editors available. So the main ones I expect most people will be using are gedit, or VS Code or Vim. Right, there are some other editors like Emacs, if for some reason you use Emacs. All of these come with syntax highlighting, and VS Code in particular comes with an IntelliSense extension, which provides code completion and stuff, which will be convenient if you use VS Code. Okay, and standard CSE lab machine commands will be available, so you'll be able to use make, obviously. You can use clang, GDB, valgrind. The manual pages will be available as well. And there'll be a calculator app available, so you can't bring your own calculator, but there'll be a calculator app in the exam environment. Yeah, so try out the exam environment this week. You can try and answer a couple of questions, submit them, see what it's like, right? And it'll just be more familiar to you which will be nice when you do your exam in 2 weeks' time. Okay, what's next? So the exam format. Okay, so there is a question in the chat about driver's license. Student ID is preferable. So if you don't have a student ID, then you have plenty of time to get one now. But in the case that you don't have a student ID, I believe a driver's license is okay, but you have to ask the exam unit. Yeah. If possible, get a student ID card. All right, so the exam format, it's marked out of 100, right? And it's going to be 50% for short answer questions, 50% for programming questions. All right, each question is answered in a separate file. So for example, question 1 will be in q1.txt, question 2 will be in q2.txt, and so on. And you submit answers using the submit command. Right, you can try that out in your labs this week. Right. Important thing is make sure you submit as you complete each question. Right. Don't just wait until the end to submit everything, because at the end of the exam you won't be given additional time to submit. You'll just be told to log out. Right. And you can check what you have submitted using the submit command. Right. So you can just type submit with no arguments and it'll list what you've submitted. Okay, so let's talk about the short answer questions first. Right, so these are the theory questions. They'll test your knowledge of the theory. Right, they'll test your knowledge, your understanding, and your critical thinking. Okay, so I know we went through a bunch of proofs for various algorithms like Dijkstra's and Kruskal's, but you won't need to know how to write proofs, right, for the exam, so don't worry about that. Okay, so with the short answer questions, we want to test your understanding, right? So most of the questions will ask for an explanation or a justification, right? So state your answer and also explain. Right. But in some cases, the question won't ask for an explanation. If that's the case, then you don't need to give an explanation. Right, so just make sure to read the question carefully to see if you need to explain your answer. Right, usually if the question's worth multiple marks, then you will need an explanation, but just check the question. All right, questions will usually have sub-questions, so question 1 might have 1A, 1B, and so on. And each question will specify a file to write your answer in. So as I said before, question 1 will be answered in q1.txt, and q1.txt will be provided, and it'll have different sections for each of the sub-questions, right? So it'll have A, B, C, and so on. So each file will clearly indicate where to write the answers. Okay. Right, don't create your own file for each question. Use the files that we give you. All right. Now for the programming questions. So the point of the programming questions is to test your problem solving and programming ability. Right. Each question will ask you to implement one function. Right. So kind of similar to lab tasks, where it's in each task you're usually asked to implement one function. The questions will include examples. They'll also provide sample test cases. And if you pass the given test cases, that means your solution mostly works. Okay. Yeah, but there might be some edge cases that might not be covered. So yeah, you might need to do some of your own testing as well. Okay, so important thing about programming questions is that your solution has to obviously attempt to solve the problem in general, right, and not just work for the given test cases, right? So, let's say we ask you to count the number of leaves in a tree, right? And one of the trees in the given test cases has a root node containing the value 15, right? And there are 4 leaves in the tree, right? If you do something like, if the root value is 15, return 4, and something similar for the other test cases, you won't get any marks, all right? So it has to solve the problem in general. Okay, and each question will specify a file to implement your solution in. So, for example, if question 8 is a programming question, then the file that you'll write your solution in is probably cube8.c. Okay. The starter version of the file will be provided. The make file and main program will be provided. So you can use make to compile. And if the solution requires ADTs, then they will also be provided. But if you think you need to use an ADT that's not provided, like you can think of a solution that uses an ADT that's not provided, you can take the ADT from the lecture code, right? So that will also be possible. But all your code needs to be in that one file. All right, so what else about programming questions? So here's a bunch of information about what's allowed. This information is also in the sample exam. So helper functions are allowed, obviously. You're allowed to define your own hash defines, structs, and enums. If any libraries are hash included, then you can use any functions from those libraries. Global and static variables are forbidden, so don't use them. If you use them, then you don't get marks for your solution. And it's very easy to avoid using global static variables because, if you have a variable that you would like to be global, then what you can do is just create the variable inside a function, pass in a pointer to the variable, right? Easy. What else? So efficiency, right? So inefficient solutions are generally allowed within reason, okay, unless we specify that your solution needs to be efficient. All right, okay, yeah. Okay, so within reason means like, let's suppose that we expect most students to implement the solution in, O of n squared time, right? If your solution is, O of n to the 5, for example, that would be way too inefficient. So that a solution might time out. All right, so yeah, and if you've got an exponential solution, then that might not, that might be too slow if the expected solution is in polynomial time. Okay, and yeah, the questions might specify additional constraints. So, examples of constraints would be no while loops, no for loops, no goto, right? So you saw that in lab 2 with the recursion lab, right? This is just a way of saying that you have to use recursion, okay? Another example is your time complexity can't be worse than ON. That might be different. For a graph question, it might be, your time complexity must not be worse than O of V squared, for example. So you might get a constraint like that. Right, and if you don't abide by these constraints, then you may receive fewer marks for the question, or 0. Right, for time complexity, usually it's, to get full marks, your solution has to have this time complexity. If it doesn't, then the maximum you can get is this many marks. Okay, and what else? Yeah, so how do we mark programming questions? Solutions will be order marked, but all of the solutions will still be manually inspected to make sure that you follow the constraints and to make sure you're not doing anything suspicious. All right, so there are no marks awarded for style, but a human marker needs to be able to read your code. right? Especially if your program doesn't pass many tests, you might be able to get partial marks. If the marker can see what your program does and see that it makes enough progress. Right, so yeah, so for partial marking, solutions receiving less than 50% may receive partial marks for making substantial progress towards a correct solution. But the resulting mark won't be greater than 50%, right? Because otherwise it wouldn't be fair towards people who got at least 50%. All right, and yeah, marks are awarded for code only. So if you just write pseudocode or an English description of your solution, that won't be worth marks. All right, so code only. Okay, so now, so some of you might have extra exam time approved by Equitable Learning Services. So in that case, you'll be given extra time to complete the exam, and this is all handled by the CSE exams team. Right, and the extra time will be listed in your allocation that you get early next week. Right, and yeah, if you are one of these students and you have any concerns, then email us. Okay, yep, so exam clashes. So some of you, unfortunately, might have another exam on the same day, but the policy is that you might have to take 2 exams in one day. We have, exams in the morning session and afternoon session, so you should be able to still do the exam. Okay, and yeah, you'll be automatically allocated to a non-clashing session. All right, yeah, so now just a couple of, formal stuff. So the exam is covered by fit to sit policy. So what does that mean? It means if you turn up to the exam and you start the exam, then you're saying that you're well enough to do the exam and to finish it. Right? And you won't be able to apply for special consideration for issues that existed prior to the exam. Right? So if you're feeling ill and you still decide to turn up and do the exam, then you won't be able to apply for special consideration. So if you're feeling sick, don't attend the exam, go to a doctor, get a medical certificate, and apply for special consideration. Right? But if you become unwell during the exam, then talk to an exam supervisor as soon as you can. Okay, and so now for supplementary exam. So if you missed the original exam due to illness or misadventure, then you should apply for special consideration. And if your request is genuine and serious, then you'll be eligible for a supplementary exam. Right? But you have to make sure that you're available for the supplementary exam. Right? So they're going to take place between Monday, the 8th of January, and Friday, the 12th of January next year. Okay. Yep, so scaling. So we get this question all the time after the exam, so I'm just addressing it up front now. So the scaling depends on the mark distribution, right? So if we see that the mark distribution is fine, then we won't scale it, otherwise we might. So yeah, we look at the mark distribution. We also look at the work of the students who barely didn't pass, and if we see that those students have actually showed a good understanding of the course content, then we may scale the mark up. Okay. Okay, so how do you revise for the exam? All right, so good idea would be to read through the lecture slides, right? Make sure that at the very least you're familiar with what was covered, like familiar with the topics, because the lecture slides are going to be available to you in the exam, right? So if you're familiar with what's contained in the lecture slides, at the very least, if you don't if you haven't fully studied for the exam, at least you know where to find the information that you need during the exam, right? What I wouldn't recommend is intending to learn stuff during the exam using the lecture slides, right? Make sure you actually read through the slides and understand everything at a basic level at least. All right, another thing is you could review the tutorial questions, lab exercises, and quizzes. Right, so tutorial questions mainly for the theory part of the exam, lab exercises and quizzes, quizzes as well for the theory. Lab exercises, you can redo them, right, to get practice for the programming part. Especially if you found some of the exercises difficult, try and redo them again, see if you can complete them quicker. Okay, and on the course website, we have a bunch of practice exercises. We do have practice exercises. I'm not logged in here, but on this page, we have a bunch of extra lab exercises. Right, so these are old lab exercises from previous terms, and you can use these to get extra practice with programming. All right, and there are also a bunch of practice exercises here on linked lists, trees, and graphs. Okay. Yeah, so make sure to practice programming, because programming is a skill that improves with practice. Okay. All right, so that is all the information. So now I'm happy to take any questions you guys have about the exam and about anything else. Yeah.
When you were talking about time complexity,
yeah.
If you said it has to be less than O n cubed,
Yeah.
if someone put O n squared, but the best one is O n, will they still get top marks if it's O n squared?
Yeah, so if we say that your solution has to be O n cubed or better, if someone's solution is O n squared, then that's fine. Yeah. Yeah, so anyone else got any other questions? Anyone from online? All right, I'll give you a second if you have any questions. All right, so if no one has any questions, then we'll move on. Yeah, remember you can try out the exam environment in your labs this week. And also there is a sample exam available on the course website now. Right, so on the sidebar, there is a link to the sample exam. Right, and you will be asked to log in, but that's fine. Just log in, you'll get to see the sample exam. Yeah, and have a look at the questions, see if you understand the content well enough to answer them. Okay, so now on to the last few slides of the lecture and of the course. So this term was, a huge effort. We had a bunch of changes this term. So one was the topic reordering. So we took sorting algorithms, which used to be covered in week 8, and we went and covered it in week 2. And I thought that was nice because it lets us practice our time complexity analysis and look at best case and worst case and average case. So I thought that was nice. So most of the slides from this term were new, and they took a long time to make. So, if you appreciate them, that's great. And we also had a few new lab exercises. So lab 1 was new, and also the hash table lab from last week was new as well. And both assignments were new this time. Right, so if it seemed like, some things were, some tests weren't released at the, time that the assignment was released, that's why, we were really, really busy with other stuff. Yeah.
Just with reference to the sample exam,
Yep.
are there work solutions available as well?
Oh yeah, so with the sample exam, we will release solutions to the sample exam at the beginning of next week. Yeah, so we want you to try the exam yourself first without the solutions, and then we'll release the solutions next week. Okay. All right, so big thank you to, first of all, our teaching staff. So we had almost 40 tutors and lab assistants this term. And they're all great tutors. They've all taught the course before, so I know how great they are. Also, big thank you to the forum staff. So some forum staff stayed up past midnight to answer questions, which they totally didn't need to, but thank you to them. Also, help session staff. So I know a bunch of times help session tutors have asked, can we extend the session because there are still people waiting, and so great, good on them. And also, thank you to some of the content or ideas, content producers. So Blake came up with the idea for assignment 1. Franco came up with the sanitizers guide, which we used in lab 1 and also is useful throughout the course. And James came up with the hash table lab exercise. Right? And also thank you to you guys for coming to lectures, going to your tutes and entertaining your tutors, and engaging with the course and giving it your best shot. All right, so now, last bit of thing about course evaluation. So my experience survey is open. So we'd like you to let us know, how did the course go? What did you like about the course? What could be improved? And let us know my experience here. Right. It's also my first time lecturing any course, so let me know what you thought about the lectures as well. Let your tutors know what you thought about their classes. Right. And they'll really appreciate your feedback, because I assume most of them will be coming back to teach the course next term, next year. All right, so why should you complete the My Experience survey? So unfortunately, we can't actually give bonus marks for My Experience anymore. So we're thinking about how else can we make you care about giving feedback? So one which we thought about was to reveal the topics of exam questions, right? Even though the exam's probably going to cover every topic in the course, still might be useful to you. So once we reach a 50% response rate, and every 4% after that, we will take a random exam question and reveal the topic and mark value of the question. All right, so at 50% we'll reveal, the topic and mark of one random question, then at 54%, 58%, and so on. Okay. Yeah, so make sure to complete a My Experience survey. So your tutors should also remind you of that in your tutes. All right, and good luck with the exam. We hope what you've learned in the course will be useful, and we hope you get the mark that you're aiming for. And that is all. So good luck with the exam, good luck with your future studies. Yeah. Thanks. All right, so it's a really early finish, so you guys can go off and, oh yeah, there is a lot of food here, so feel free to collect your last candy for the time. Yeah, just take all of it. I don't want to take anything back.